In today's topic, we're going to discuss periodic table strengths. We'll see electron affinity, electronegativity, atomic radius, and ionization energy. Let's begin with electron affinity. Electron affinity is the energy released when an electron is added to a gaseous atom. The atom then turns into an anion in the process, which means it turns into the negative ion. The process of fluorine can be represented as follows. So, fluorine plus electron in the gaseous phase will give you negative ion of fluorine. You can represent it using this diagram. When fluorine atom gains an outer electron, it turns into fluorine ion with a negative charge. So it is anion. Next we look at the trend of electron affinity. Electron affinity is also a description of how likely an atom is to accept an electron. The smaller the atom, the greater the ability of an atom to receive an electron due to the proximity of nucleus. So, electron affinity increase across a period and it decrease down a group. Let's see why it increases across a period. The reason is that there is an increased nuclear attraction and the element on the right side of the table, except for the noble gases, are close to achieving the full octet. So they really want electron. Why do electron affinity decrease down a group? The reason is that there are more orbitals and the atomic radius is greater. Since the atomic radius is greater, there is less nuclear attraction, so there is also less electron affinity. Therefore, electron affinity increases across a period and it decreases down a group. Next is electronegativity. Electronegativity is a property that determines how strongly the electrons are held by an atom within a compound. How strongly an atom can bound with another atom within a compound is called the electronegativity. It increases across a period. Why? Because it can be explained in terms of atomic structure. Across a period, the number of proton increases and number of shell remains the same. Therefore, electronegativity increases across a period. Next is electronegativity decreases down a group. Why? The reason for this is that there are greater numbers of shell. The outer electron experience a shielding effect and therefore don't feel the pull of proton as much as the inner electron do. Atomic radius. Atomic radius is the distance from nucleus to the border of the outer orbital. Atomic radius decreases across a period because as electrons are being added to the same energy level, protons are also being added to the nucleus, which pulls the electron with a strong force. Therefore, it decreases across a period. Atomic radius increase down a group. Why? There are two reasons. First is electron enters a whole new energy level in next period, and the second is the core electron shield the outer electron from the pull of nucleus, therefore increasing the atomic radius down a group. Next is ionization energy. Ionization energy is the energy required to remove one outer electron from a gaseous atom. It increases across a period. Why? Because proton increases and number of shell remains the same. Therefore, net nuclear charge is increasing. Thus, ionization energy is also increasing. And it decreases down a group. Why does it decrease down the group? Because the number of electron increase, so there are more shells. Since there are more shells, the electron are held more loosely. The electron are held more loosely since they are farther away from the pull of nucleus, making it easier to remove an electron. So it decreases down a group and it increases across a period. First ionization energy is the energy required to remove the first electron, which is the outermost electron in highest energy sublevel. So in this case, this is the outermost electron, and it requires uh, it requires less energy to remove. The smaller the atom, the more force of attraction by nucleus on the outer electron, hence higher ionization energy. So, as we said, ionization energy increases across a period and decreases down the group. Let's summarize what we learned. We know that periodic table is divided into two parts, metals and non-metals. So on the left hand side, all of these are the metals, and on the right hand side, these are the non-metals. Periodic table is also divided into groups and columns. Groups and periods, or rows and columns. Groups, also known as columns. Elements in a group have similar outer electron configuration and similar chemical properties. The group number of the element corresponds to the number of valence electrons. So if I say that hydrogen is in group number 1, I say that valence electron of hydrogen is 1. If I say fluorine is in group number 7, I know that valence electron of fluorine is 7. Period or rows. There is a gradual change in physical and chemical properties as we move across a period. The period number tells us energy level where the outermost electrons are found. Some important groups to remember from the periodic tables are four. Number 1, number 2, number 7 or also 17, number 8 also 18. Number 1 is alkali metals, number 2 is alkali earth metals, number 7 is halogens, and number 8 is noble gas. From the periodic table, we can see elements electronegativity, electron affinity, atomic radii, and ionization energy trends. Electronegativity, as we said, is tendency of an atom to attract a bonding pair of electron. Electronegativity can range from 0.7 to 0.4. Electron affinity is energy released when an electron is added to the neutral atom to form negative ion. So, electron is released and negative ion is formed. This is electron affinity. Atomic radius is distance between nucleus and outermost orbital. And ionization energy is energy required to remove an electron from an atom in a gaseous phase, which will give you anion. Electronegativity increases from left to right. Electron affinity also increases from left to right, and ionization energy increases from left to right. But atomic radius decreases from left to right, or you can say that atomic radii increase from right to left. Same as electron negativity, electron affinity, and ionization energy increases down the period, but atomic radii increases down the period or decreases up the period. This was all about periodic table trends. If you have any questions, don't forget to leave in the comment section. If you like my video, don't forget to subscribe. Thank you.